Let's next begin to discuss how we can divide radical expressions. To do this, let's develop a rule, just like we developed a rule when multiplying radical expressions. And let's look at these couple of examples to see if these statements are true. So let's look at the square root of 81 over the square root divided by the square root of 9. If we were to divide those two, we're asking, is this the same thing as the square root of 81 over 9? And so let's do a little bit of math. If we were to take the square root of 81 first, that would be the number 9. And the square root of 9 is 3. So 9 divided by 3 is 3. Is that the same thing as dividing first? Well, if we would divide 81 divided by 9, we would get 9. And the square root of 9 is 3. So it does appear so far that these are the same. Let's do it again 2 more times with similar numbers that we understand. So the square root of 16 is 4, divided by the square root of 4 is 2, so 4 divided by 2 is 2. Or if you would do it the opposite way, you could take the division first and say that 16 divided by 4 is 4, and the square root of 4 is 2. So again, these are the same thing. And if we do it one more time, we see the same result. This helps us understand what our quotient rule is for radical expressions. The quotient rule is that if you are dividing 2 different radicals, the radical square root of a over the square root of b, that's the same thing as taking the square root of the quotient altogether. And so now that we understand this, let's see how we can use this to help us simplify radical expressions that are being divided. So the square root of 27 divided by the square root of 3. I don't know what either of those 2 square roots are because they're both irrational numbers. But if I use my quotient rule, I could rewrite this expression as the square root of 27 divided by 3. And I know what the square root of 27 divided by 3 is, because I know that 27 divided by 3 is the number 9. And now that I know it's just the square root of 9, I can simplify this to 3. So the quotient rule helps us simplify these expressions. Now let's look at the square root of 25 divided by 9. For this one, I don't know what 25 divided by 9 is off the top of my head. It's going to give me some decimal. But I can use the quotient rule kind of in reverse for this one and break up this radical into 2 different radicals. The square root of 25 over the square root of 9. And I know what both of these square roots are because 25 and 9 are perfect squares. This is 5 and this is 3. So now I have a simplified expression. So try the next 2 examples on your own by pausing the video, simplifying each one of the 2 expressions, and then resuming it once you think you have a simplified quotient. Okay, so at this point, hopefully you've done the next 2 examples, and I'll do them along with you to see if we get the same result. For the square root of 49 divided by the square root of t squared, let's break that radical up into 2 different expressions and simplify each one of them. The square root of 49 is 7, and the square root of t squared is t. And for our last one, I'm going to write this as one radical, 8a to the 7th over 2a, and simplify that fraction now. That gives me 4a to the 6th. And to simplify that, the square root of 4 is 2, and the square root of a to the 6th is a to the 3rd. Now the expressions do start to get a bit more complicated. If you look at each one of these problems, it will involve a couple more steps, but a hint is that it is often helpful to reduce your fractions before you try to simplify the square root operations and do any of those, perform them. So let's look at the square root of 14 over the square root of 50. I don't know what either of those 2 square roots are. But if I would rewrite this expression as 14 over 50, and then reduce that fraction as much as possible to give me, that would be the square root of 7 over the square root of 25, I now see that in the denominator of my fraction, I have the number 25, which is a perfect square. So now I'll break it back up again into two different expressions, and I'll write my final simplified expression. My numerator stays the square root of 7 because that's simplified already, but my denominator is just 5. So that's a simplified form of letter A. Now let's look at letter B. Again, I look at this fraction and I see, I think I can reduce this fraction. So I'll divide 48 divided by 3. Let me write it with the fraction here. 48 divided by 3 is 16. And I have x to the third over x to the 7th. So that gives me x to the 4th in the denominator. Now I can split this up again into the top, take the square root of the top and the bottom. Or, once we get the hang of it, we know that the square root of 16 is going to be 4, and the square root of x to the 4th is going to be x squared. So I kind of skipped a step there to kind of know that I'm going to be taking the square root of both of them, so that's my answer. So go ahead and pause the video now and try to do letters C and D on your own. Once you think that you've got your simplified form for both of them, resume the video, and then you can check your answers. Okay, hopefully at this point you now have simplified expressions for C and D. Let's check our answers. For this one, I have the square root of 5 over the square root of 45. I'm going to rewrite that as 5 over 45 under 1 radical sign, and then I'm just going to rewrite that as the square root of 1 over 9. And I can do this because the square root of 1 is 1, so the numerator is now 1, and the square root of 9 is 3, so that's my simplified expression. And for my last one, when I simplify this fraction first, I get 2 over 25, and then I get x to the third in the numerator. Now, I'm going to actually split this one up and write it out. That's 2x to the third over the square root of 25. And I have to do a couple things here. I know that the square root of 25 is going to be 5. But in the numerator, I can also simplify x to the third, okay? Because that's the same thing as x squared times x. So that's going to be 2 times x squared times x. And the square root of x squared is x. So my final answer is x, because that's what I get from this part right there, times 2 square root of 2x over 5. Finally, now that we know how to simplify these expressions, there's one more concept we have to master when dividing, and it's called rationalizing the denominator. To rationalize the denominator is a procedure to find an equivalent expression without a radical in the denominator. So in both of these examples that I have up here, the square root of 7 here, or over here when I simplify this one, I'm going to have a radical in the denominator, and I never want to finish a radical expression by leaving a radical in the denominator. I want to have a rational number down there, all right, some number that's not a radical. So I will not be able to call this first expression 8 over x to the 7th simplified. So to do this procedure, we just have to remember how to change and write equivalent fractions. So what I can do, this is rationalizing the denominator, I can multiply this fraction by the square root of 7 over the square root of 7. Because that's the same thing as the number 1. And when I do that, okay, I end up getting, in the numerator, I get 8 times the square root of 7. And in the denominator, the square root of 7 times the square root of 7 is just 7. So now this is my simplified way of expressing this previous expression. That denominator is now rationalized because I do not have a radical. Now let's look at the next one. Square root of 7a over 20. For this one, let's go ahead and try and simplify it as much as possible, because I know that the square root of 20 is the same thing as the square root of 4 times the square root of 5. And I know that the square root of 4 is 2. So I could rewrite this as square root of 7a over 2 square root of 5. But again, this cannot be my final answer because I have a radical in the denominator. So I need to rationalize the denominator. And just like in my previous problem, where I multiplied it by some unit of some value of 1, square root of 7 over the square root of 7, I'm going to do a similar process for this one, except this time I'm going to multiply it by the square root of 5 over the square root of 5. So I multiply it by root 5 over the square root of 5. And here's just where we have to be careful with our multiplication. Since these are both radicals being multiplied together, it stays as a radical, square root of 35a. And in the denominator, when I multiply square root of 5 times the square root of 5, I just get the number 5. And then when I multiply that with the 2, I get the value 10. And now you can see, because I've rationalized my denominator, I no longer have a radical in my denominator.